So in this video, we're going to talk about how to graph square root functions and describe some key characteristics. So when we start off talking about square root functions, let's talk about the parent function. The parent function is given by the equation f of x equals the square root of x. So let's graph this using this table. So we start off with x equals 0, which gives us f of 0 equals the square root of 0. The square root of 0 is 0. Then we have 1, so that gives us f of 1 equals the square root of 1. The square root of 1 is 1. We have f of 4, which is the square root of 4. The square root of 4 is 2. And finally, we have f of 9, which is the square root of 9, and the square root of 9 is 3. So now let's plot these points on our grid. We have 0, 0, 1, 1, 4, 2, and 9, 3. And so when we connect these points, we now have the graph of our square root parent function. So whenever we're describing these functions, we want to think about some important characteristics. So we're going to be talking about the domain and range, the intercepts, where the function is increasing and decreasing, any maxima and minima, and the end behavior of the function. So let's start talking about these characteristics as they relate to the square root parent function. So let's start off with the domain and range. Remember that the domain is all possible x values of a function, and the range is all possible y values. So if we're describing the domain of the square root parent function, notice that it starts off at 0 and then includes all x values going in the positive direction. So we would say the domain is from 0 to positive infinity. We can write it as an inequality by saying 0 is less than or equal to x, which is less than infinity. The range starts off also at 0 and then includes all y values going in the positive direction. So we would say the range goes from 0 to infinity, which we can write as the inequality, 0 less than or equal to y, because we're talking about range, which is less than infinity. So all real numbers are not included in the domain of a square root function. So why do you think this is true? Let's look at the parent function f of x equals the square root of x. What x values would not be included in the domain, and why do you think this is true? So if we look back at the graph, notice that the domain is all the positive values of x. So these negative values of x are actually not included in the domain. Let's talk about why that is. So for example, if I tried f of negative 4, and if I plugged it in this function, I got the square root of negative 4. Remember back from semester 1 that this is the square root of negative 1 times the square root of 4, which gives me I times the square root of 4. So that's 2I. Well, if we look at our xy coordinate plane, we don't include any complex or imaginary numbers. We're talking about real numbers here. So that's why we restrict the domain of square root functions to make sure that we're only talking about real values. So we're going to restrict this function and say that whatever's under the square root, so in this case that's x, has to be greater than or equal to 0. So that's why the domain of this function is all the x values from 0 to infinity. So now let's talk about the intercepts of this function. So remember, intercepts are where the graph crosses the axes. The x-intercepts occur where the graph crosses the x-axis. X-intercepts have the form x0 because remember the y-coordinate will be 0 where you have an x-intercept. So you can see in the graph of this polynomial, it has 3 x-intercepts, negative 1, 0, 2, 0, and 4, 0, where it intersects the x-axis. The y-intercept is where the graph crosses the y-axis. It has the form 0y because remember that x will equal 0 where you have a y-intercept. So in this graph, you'll see that 0, 8 is the y-intercept of this polynomial function. So let's talk about the intercepts of this square root function. You can see the x-intercept where it crosses the x-axis is here at the origin at 0, 0, and that is where we have a y-coordinate that's 0. Coincidentally, the y-intercept is also at 0, 0 because that's where the graph crosses the y-axis. That's where we have an x-coordinate that's equal to 0. So for the parent function, the x-intercept and y-intercept are both going to be at the origin. So now let's talk about where this function is increasing and decreasing. So to describe increasing and decreasing, what we're going to do is look at an interval of x and then study the behavior of y. So a function is increasing on an interval if the y values increase as the x values increase. So for example, you can see in this function pictured here, if I look at the interval from negative infinity to negative 1, okay, so those x values going from negative infinity to negative 1. What's happening in y is that y is increasing on this interval. So we would say it's increasing on the interval from negative infinity to negative 1. And also it is increasing on the interval you can see here from 2 to infinity. Because notice that as I go from left to right, my function is going up. Similarly, this function is decreasing if the y values decrease as the x values increase. So you can see in this interval from negative 1 to 2, my function is going down. So that means that my graph goes down as I go left to right, so it'll be decreasing on this interval from negative 1 to 2. So if we look at the square root function, notice that it is always increasing, right? It is always going up. So it's going to be increasing over the interval that's its entire domain. So we would say it's increasing from 0 to positive infinity. It's decreasing actually never, because the function is never going down as you go left to right. So now let's talk about a maximum or a minimum value. The absolute maximum is the highest point on the graph of a function. In other words, it's the largest y value. So in this example, you can see the highest value here is at y equals 4. So the 0.44 is a maximum of this graph. If we're talking about the absolute minimum, that is the lowest point on the graph of a function. It's going to be where you have the smallest y value. So that's going to be at this point right here where y is 0. So 2, 0 is going to be the minimum of this function. So if we look at our square root function, the maximum is going to be the highest point on the graph. Well, we can see this graph is actually going on forever up, right? It's always increasing. So there is no maximum value because it's just going to keep going up and up forever. However, there is a minimum because notice at this point 0, 0, that there's no points lower than that, right? That's our lowest point on our graph. So we would say 0, 0 is our minimum, or you could say it has a minimum value of 0 at x equals 0. Okay, so that's another way to talk about a minimum value, because we're talking about the value of the function, right? The value of the function is 0, and that's why we have a minimum there. So we can also talk about the end behavior of a function. End behavior is basically what we're describing as the function goes on forever. So remember, whenever we look at a picture of a graph, that's just a snapshot of the graph. The graph, in fact, does go on forever in both directions, but it's beyond what we see in our picture. So that's what we're talking about with end behavior. What happens to the function f of x as the x values go to positive infinity and negative infinity? So in this example, you can see as this graph goes to negative infinity, my x values get smaller, and so do my f of x values. F of x tends to negative infinity. So that's why we write as x approaches negative infinity, f of x approaches negative infinity. As x values increase as it goes to the right, we would say as x approaches positive infinity, f of x approaches positive infinity, right? Because this function is increasing. So what happens as the function goes on forever in this case? Well, we can see here this function starts at 0, 0, and then it heads forever in the positive infinity direction. So we would say as x approaches positive infinity, well, what is now happening to f of x? Well, f of x we can see is increasing. So we would say as x approaches positive infinity, f of x approaches infinity. So remember, in general, with square root functions, the parent function is always going to be f of x equals the square root of x. All other square root functions are transformations of this original parent function. So all other square root functions will have the form f of x equals a times the square root of b times x minus h plus k, where a, b, h, and k are constants. We'll talk about this more in lesson 6.05 when we talk about transformations. So let's look at this square root function f of x equals the square root of x plus 4 minus 3, and let's describe its key characteristics. So let's create this table of values to generate the graph. So I'm going to start off by plugging in negative 4. So I have f of negative 4, which is the square root of negative 4 plus 4 minus 3. So that gives me the square root of 0 minus 3, which is 0 minus 3, which equals negative 3. Now we have f of negative 3. So when we plug that in, we get the square root of negative 3 plus 4 minus 3, which is the square root of 1 minus 3, which equals 1 minus 3, which is negative 2. Now we have f of 0, which equals the square root of 0 plus 4 minus 3, which is the square root of 4 minus 3, which is 2 minus 3, which equals negative 1. And now we have 5, so we have f of 5, which equals the square root of 5 plus 4 minus 3. The square root of 5 plus 4 is the square root of 9 minus 3. So we have the square root of 9, which is 3, and 3 minus 3 is 0. So let's plot these points now on our grid. So we have negative 4, negative 3, negative 3, negative 2, 0, negative 1, and 5, 0. So when I connect these points, I now have the graph of my square root function. Draw that a little better. So you can also graph this function using Desmos or your graphing calculator. So I just want to show you how you would graph this function in Desmos. So what you're going to do is you're going to go to Desmos and you can type y or you can type f of x. So you can type y equals, and then you're going to choose here to choose the square root. So you're going to need the keyboard to do the square root. And then you type x plus 4. And then you're going to want to click out of the square root to write the number that's on the outside. So you type minus 3. And then now you have the graph of this function. So now that you have the graph of this function, let's go ahead and talk about its key characteristics. So let's start up by talking about the domain and range. Well, we can see from the graph that the domain starts at x equals negative 4, and it goes to the right in the positive direction. So we would say negative 4 to positive infinity. We can write this as an inequality by saying negative 4 is less than or equal to x, which is less than infinity. We can also determine this algebraically. So what it means by think about the restrictions is, remember, we cannot have a negative value under the square root. So we would say that x plus 4 is greater than or equal to 0. So we can now solve this inequality by subtracting 4 from both sides. So that tells us that x needs to be greater than or equal to negative 4, which is the same thing that I've written right here. So the range now, we can see that we have all values starting at negative 3 and then going up to positive infinity, which we can write as negative 3 less than or equal to y less than infinity. So the reason it starts at negative 3 is because that's the y value that corresponds to f of negative 4, right? So if we do f of negative 4, we get the square root of negative 4 plus 4 minus 3. So that is the square root of 0 minus 3, which is 0 minus 3, which equals negative 3. So that's how we have that value. So now we can find the intercepts of this function. We can find the intercepts based on the graph. Remember, if you're in Desmos, if you click on the intercepts, it will tell you the coordinates. So the x-intercept, where it crosses the x-axis, will be at 5, 0. Remember, at the x-intercept, we have y equals 0, so you can also determine that algebraically. You just set the function equal to 0, and then you solve for x. So when I do this, I can solve by adding 3 to both sides. And when I do that, I get 3 equals the square root of x plus 4. I can now square both sides. So I get 9 equals x plus 4. Subtract 4 from both sides, and I get 5 equals x. So that's why we have an x-intercept at 5. The y-intercept is where the graph crosses the y-axis. So that is at 0, negative 1. So you can also determine that by plugging in 0 for x. So we get f of 0 equals the square root of 0 plus 4 minus 3, which is the square root of 4 minus 3, which gives us 2 minus 3, which equals negative 1. So that's how you determine the intercepts of this function. So now let's talk about where this function is increasing and decreasing. So it's increasing, let's see, it starts off at negative 4. So this interval from negative 4 to infinity, it looks like it's always increasing. So we're going to say that this function is increasing on the interval from negative 4 to infinity. It's never decreasing. Notice that it's never going down as we go from left to right. Now let's talk about a maximum or a minimum. Well, this function is increasing. It just keeps going higher and higher. So we would say there is no maximum, but it does have a minimum value at this point, which is -4, -3. Remember, we can also say that it has a minimum value, okay, because that's the value of function. So we would say the minimum value of -3, because remember the value of the function is the y value at x equals -4. So now let's talk about the end behavior of this function. Right now we want to think about what's happening as this function goes to infinity. Well, the only infinity this is headed towards is positive infinity. So we would say as x approaches positive infinity, we would say f of x. Well, what's happening to f of x? It's getting bigger and bigger, right? So we would say f of x is also headed to positive infinity. So now you can pause this video and try this problem. So go ahead and graph f of x equals 2 times the square root of x plus 5 minus 4 and try to describe its key characteristics. So now let's go over the answers to this problem. So the domain you can see from the graph goes from -5 to infinity. Those are all the x values, and the range is from -4 to infinity. The graph you can see has an x-intercept at -1, 0 and a y-intercept at 0.472. Remember that in Desmos you can click on those points to see their coordinates. This function is always increasing, so it's going to be increasing on the interval from -5 to positive infinity. It does have a minimum value, so you can see this value right here is the lowest point on the graph, which is at -5, -4. Or you can also say that it has a minimum value of -4 at x equals -5. The end behavior is that as x approaches positive infinity, which is where this graph is headed, the f of x values are also approaching positive infinity. So in summary, remember that when you're describing square root functions, it is important to think about several key characteristics. You want to think about the domain and range, any intercepts, whether the function is increasing or decreasing, whether it has maxima or minima, and what is the end behavior.